Now that we are done with lasso regression for the feature selection, the next one which comes in the queue is regression. Right, let's just understand what exactly it is and how does it work. So regression is pretty much similar to the lasso one. The difference is regression never does the penalization and zeroize the new coefficient, right? So it will never make it zero. So this is little lenient, where lasso regression is pretty aggressive, right? The lasso regression is pretty aggressive. It zeroizes the new coefficient, where in regression it gives you the value which can be close to zero, but mostly it doesn't gives the new coefficient as zero. Why does it happens? Lasso regression penalizes the absolute value of the coefficients. For example, this was our original initial coefficient, and when it does the penalization, it did the penalization on initial absolute coefficient score directly, while in regression what it does is it does the penalization on the squared squared coefficients, right? Coefficient, that's what the main difference is. Hope it has clarified. Now instead of going deep into the mathematics of this thing, I would directly take you to the Python and I will show you how to implement regression in Python. Let me take you to the Python. So here we are in Jupyter Notebook, and like you can see here, I have already imported all the dependencies which are needed: trend, test, split, range, and standard scalar. The same data which we had used for lasso, same we are going to use over here as well, which has 31 columns and 5 rows. We splitted that into independent and dependent features. X is the set of independent features which will help in predicting, and Y is the target feature which we also say as dependent features. Now what we will do is, first we will do the scaling of this data, okay, which is independent features, right? So for that we require the standard scalar. Here we have the standard scalar. Let's create the scalar instance. Scalar equals to standard scalar instance is created, right? And then we're gonna say x scaled. We are going to scale the independent features, right? So scalar dot fit transform, and inside that I'm going to put the data which I need to scale. So now that is scaled, next comes is doing the trend test split of the data, right? So here I'm going to say trend test split, and I'll just press over here shift plus tab and scroll it down so that I could copy the syntax very quickly, and we would not require to spend a lot of time into writing this syntax. Right, now here we are, instead of x, now here we have the x. Now instead of x, what I'll do is I'll put x scaled, because this is the data which we are going to be using further, right? So this is done. If you are someone who have already trained few of the models, then you already understand what trend test split is, so I'm not going to get into the detail for that. Now next one comes is regression, creating the instance for regression, right? So here we go, reg, I'm just going to say reg, and then here I need rage. And where did I get that? So that's something which I have imported over here. All right, you can see. Now into this we need to supply the value for alpha. If you remember, we had done this in lasso regression as well, right? This is for the regularization. Okay, now this is done. We have created the instance. Next thing which we gonna do is we are going to train the model. So for that we're gonna say reg, this one, all right, dot fit, and inside that I'm going to put x scaled, x train, because here x train is the data set which contains scaled data, right? So we don't need to be worried about it. Y train, all right, this is what we got. Next thing which comes is finding the coefficient, taking out the coef out of this model. So this is the set of coefficient which we have got. Now we don't know which coefficient refers to the which feature, right? So we are going to do this. We are going to create feature importance, and over here I'm going to say feature. So we require two things. one is feature name. Against that we want to put the importance, I mean coefficient of it. So here I'm going to say feature comma coef for feature comma coef in zip x dot x dot columns comma range. This one, this is exactly what I am looking for over here. So let me explain you what exactly this is. So X is my data set. If you remember over here, I had taken the set of independent features. Out of that X, I'm only taking the list of the columns. Now here ridge is my trained model, and out of that I'm taking the coefficient, and I'm concatenating both, and out of that I do the iteration, right? And then what I'm going to do is I'll print it right over here. Let's just see, here we got that. Now the next thing which I'm going to do is I'm going to convert this into the pandas data frame and sort it into the descending order, right? So I'm going to say feature FIDF, which is nothing but feature importance data frame. All right, now here I'm going to say pd dot data frame. So this name you can keep anything. Hope you are you are already understanding that it's not mandatory that you need to keep the same name. Okay, so over here I'm going to put data frame name, which is feature importance. I'll just copy it from here so that we avoid the spelling mistakes, comma columns, column name we need to supply, and that I'm going to say first column name it as features, second column name it as coefficient. And once this is created, let me print it. So this is what we got. Now the most important feature I want to keep at the top. So for that I'm going to say sort values, and inside that I'm going to say by equals to coef, and here I'm going to say ascending equals to false, so that it sorts that into the descending order. Now if you see, these are, if you want to take top 5 features, then these are the set of top 5 features which you should be selecting for your model training and model building. Okay, so this is how you can use the utilize ridge regression for feature selection. Now point if you should notice, if you notice, is this is what we have over here. You see none of the features have the coefficient as 0. That's what ridge regression do. If you remember the previous video on lasso regression, into that we had got many features which were having the 0 coefficient. So that's where ridge regression makes the difference. I hope it was easy for you to understand. Just in case of any doubt, put that into the comment section. I'll definitely try to help you out. Until then, happy learning. Wish you very all the best.